Hi, my name is Divyansh Gandhi and welcome to Quantum Computers Explained. To get to that, first we have to see what are computers. Computers are all around us and they perform really smart things, but under the hood, they're actually dumb. All they really work upon is flow of electricity or no flow of electricity, which is represented by bits, 1 for flow of electricity and 0 for no flow of electricity. Simple, isn't it? Well, now you may ask, how are bits represented at the most basic level? How does a CPU know what is bit 1 and what is bit 0? This is done by a simple device known as a transistor. Transistor acts like a simple switch at the most basic level, which when turned on represents the value of bit 1 and when turned off represents the value of 0. Many of these transistors are being turned on and off right now in your device while you are watching this video. Also, many of these transistors come together to form logic gates. Logic gates are like really small calculators which perform really small calculations at a really fast speed. So, what does this mean? This means when many logic gates are connected together, they form your logic system or your CPU. Now, this CPU can be used to perform heavy tasks such as movie editing and light tasks such as watching a YouTube video. Well, if it is so easy and straightforward, then why do we need a new type of computer? This is because to decrease the size, we have constantly been shrinking down the size of the transistors on a chip. Now we have reached the quantum realm, and in this realm, particles behave weirdly and spookily and no one knows what is happening under the hood. But what if we could use this quantum behavior for our benefit? The way the particles behave in the quantum realm, the weird and spooky behavior, can actually be used to exponentially speed up the processing power of computers. This is the idea behind quantum computers, using the quantum weirdness to power the next generation of supercomputers. But how do we make a quantum computer? While normal computers work on bits, quantum computers work on quantum bits, or qubits for short. While normal bits may represent only one state at a given time, either 1 or 0, quantum bits can actually exist as both 1 and 0 at the same time. This property of qubits in existing at multiple states at once is known as superposition. In superposition, until observed, the qubit remains in a proportion of the 1 state and the 0 state. When it is observed, the wave function of the qubit collapses into either of these states, which has the maximum probability of existing. Say, for example, you have 4 bits. Now, these 4 bits can represent 16 values of information. Now, in normal processor, out of these 16 values, only one value can be used at a given time. But in quantum computers, qubits can represent all the 16 values at the same time. This gives an exponential speed increase in the processing power of quantum computers. So, for a general n number of qubits, they can represent 2 raised to the power n bits of information. Superposition also plays a crucial role in the formation of molecules. You may have heard about the covalent bond in which atoms come together and they share electrons. Now, the shared electrons exist in superposition with both the atoms. So, it's superposition that you should thank for forming our bodies and the food we love and everything that we can see. Because if it wouldn't have been for superposition, our body and all the atoms in our bodies would fall apart. Another key property used in the formation of quantum computers is quantum entanglement. Entanglement is like a strong, deep connection between 2 or more quantum entities with which they can communicate with each other faster than the speed of light, even if they are separated over millions and billions of miles away. If this doesn't blow your mind, I don't know what will. Now, there is no actual communication between these quantum entangled bodies and we can't transfer information via this method. But what we can do is when we measure one quantum body's properties, we can automatically deduce the properties of its entangled partner. Quantum entanglement is a game changer for the development of quantum computers. This is because when you measure one qubit's information, you can automatically deduce the information of its entangled partner. This gives an already blazing fast computer even faster processing speeds. Quantum computers and their enormous computational power may have enormous uses in the future, but right now they are used for only 2 main things: database searching and prime factorization. Future uses include simulation, machine learning, quantum cryptography and many more. Right now, quantum computers are in their initial stage and only time will tell that will they be able to provide the revolution that they promise. Quantum computers have a really long way to go, but I hope this video provided you a better perspective about them. Thank you.